Hello and welcome to SUE QLA Test Hole Consultant Training. My name is Aisha Motri and I manage the Overhead Subsurface Utility Engineering program for the department. Our goal is to provide guidance to streamline the submission process for approval. We hope you find this information valuable and we encourage you to use this as a resource when working on GDOT projects. During this training, we will cover federal and state guidelines, plans and productions. Within plans and productions, we will cover test hole forms, UTLE and or QLA DGNs, test hole tables, and CSV files, dry hole justification and or documentations, files and or documentations, and the big picture. Test holes are documented in the federal standard ASCE 3822, which is the Overhead Subsurface Utility Engineering Manual. I will begin with only two definitions in the manual to encourage consistent terminology to be used within our industry. Beginning with locating. By definition, locating is not considered QLA. It can lead up to QLA information based on the information you discovered during the investigation, but locating by itself is not considered QLA. Moving down to metadata. Metadata is the typical attributes discovered during your SUE investigation and should be captured within your findings to a degree depending on your scope.
QLA requirements are well defined within Section 2.5 of this manual. For the purpose of this training, I will focus on the vertical and horizontal tolerances. For the vertical tolerance, it is 0.1 feet. For the horizontal tolerance, it is 0.2 feet.
Moving on to Commentary 2.5 section within the manual, we want to ensure you are not completing test holes that were previously marked by one call. You are responsible for completing all required work for this deliverable. This is very risky. Remember, a professional seal and signature is required for each deliverable, so you are liable for work submitted. Also in this section, it is noted when the utility cannot be visually confirmed or measured due to high water tables or slumping soils. We consider this a dry hole. Further guidance will be provided later in this training. Now the state guidelines. What you see is a screenshot of GDOT-SUE Scope of Services, specifically for QLA investigations. Going to cover some highlights from this section. However, you are responsible for being in compliance of all the details required for QLA investigations. Starting with bullet 2, neatly cut and remove existing pavement with the cut area not to exceed 144 square inches. Excavate test holes in such a manner as to prevent any damage to warpings, coatings, or other protective coverings such as vacuum excavation or hand digging. Be responsible for any damage to the utility during excavation as required by Georgia state law, and that's Georgia Code Title 16-7-25. Provide a permanent restoration of the pavement within the limits of the original cut at the time of backfill. So if a test hole is excavated in an area other than roadway pavement, that area that's disturbed shall be restored to equal or better than the condition before excavation. Elevations of top and or bottom of utility tied to data of the furnished plans are required. We will discuss later during this training when bottom elevations are required for utilities. Elevation of existing grade over utility test holes are also required. The SUE consultant shall perform all required survey work. That includes the designation, surveying the designated line work, as well as all of the survey required within the test hole itself. Outside diameter of the pipe or width of duct banks and configurations of non-ease multi-duct systems. And of course, moving down to the vertical and horizontal tolerance, accuracy tolerances. So the elevation, which is the vertical tolerance, is 0.1, which is in compliance with 3822, and the horizontal accuracy tolerance is 0.2 feet. Last but not least, the consultant is responsible for maintaining that pavement restoration for 1 year after installation. Of course, before you start any work with the department, be sure to refer to your scope for the project. On this slide, you see two examples of SUE scope with test holes included. So in the top slide, you have OPD's contract. Typically, it will only be included on this one line item where it says perform up to 20 QLA test holes as needed. Most of the scope and assumptions will be recorded within the spreadsheet itself for all of the scoping documents for that project. Below, you will see the on-call contract example with a little more detail and within our scope that's emailed to the consultants. So you can see all of the assumptions that we include for those projects. But either way, you will at a minimum see an estimated number of test holes needed for that project. We strongly encourage you to participate in the scoping meeting. Typically, we'll have a SUE representative within the meeting, and you will have the opportunity to ask any questions you may have for that project. You are also expected to communicate scoping details to your team members. We are always here to assist. However, you are responsible for communicate the project needs with your team. SUE deliverable checklists are due for each submission and is accessible on the GDOT homepage. See the link below, or you can simply Google GDOT homepage. Select doing business with GDOT, then services, then select utilities. Next, select subsurface utility engineering. Then scroll down and select SUE deliverables checklist. Make sure your pop-up blocker is unchecked because it will populate all of the SUE deliverable files for your use.
Kyle Griffin. I'm a GDOT SUE reviewer, and today we'll be going over the two different checklists for QLA submittals and explaining the key differences between the two. We'll also be going over the SUE utility legend sheet and the test hole forms. So if you see this slide here, it's got the same consultant underlined. So this checklist is if you've completed a QLB investigation and you are now doing the QLA. So you'll need to fill out all the information within this box on the front sheet. You will submit an initial checklist for your initial deliverable, and you will submit a final checklist when the final package is requested. We do not ask for intermediate deliverable checklist for sequential submittals like second or third submittals. So this is the CSV file. So if you've completed a B or if you did not complete a QLB, you're still required to submit a CSV file, and it is in Excel format. And you will need to have the proper name. So the proper name would be the PI number underscore SUE .csv, and Raymond Chandler will be giving additional details about this CSV file later on in this presentation. As of right now, pictures are optional on your test hole forms. Later on, we'll discuss the standardized test hole forms that we are currently working on, and whenever those become mandatory to use, which will be in October 2025, those will require a photo of the test holes. So for the final accepted SUE deliverable submittal, you will need to include your Georgia PE or RLS stamp signature on the test hole table only, not the test hole forms. So in addition to if you've completed the QLB, you will also put a note in the general notes sheet of the plan set. This is usually the 24-000A sheet. You'll need to add a note to that sheet stating when the SUE investigation was complete and who it was completed by. So if you completed the B, now you're doing the QLA, you will need to save all or make the updates in the UTLE DGN file, and that includes your designated line work, and that line work must tie back in to the previous QLB database. The test hole symbols will also be placed in the UTLE file. The test hole symbol will need to be the survey location of that test hole that you performed. So this is the signature page here. So it says please indicate any other project specific items as documented in the SUE contract task order if applicable. So if you've been issued a job order or if you're one of our own calls and you've been issued a job order, we have a good idea of what's in your scope. But if you doing a QLA off of Office of Program Delivery, sometimes we don't get those, and you'll need to attend the scoping meetings to know what they expect you to do, if you have any exclusions. So please put those details here, as we do not always see those scopes for OPD's contract. And also the second item here, previously in the checklist, you may have seen some boxes that said included or excluded. So if you clicked or checked excluded for any of the items on the checklist, be sure to indicate here a reason for why those certain items were excluded. Okay, so this checklist here is if you did not complete the QLB investigation, you're now doing an A behind someone else that done the B. So you will need to create a new reference file called the PI number underscore QLA.dgn. So, and included in your general notes, previously, if you've done the A or if you've done the B previously, you put that note in your general notes. But if you did not complete the QLB, you will need to put a note in your test hole data table stating when the investigation was completed for the QLA and who it was performed by. So we are currently working on revising the SUE utility legend sheet to standardize the utility abbreviations. And also we are currently working on a test hole DGN cell. As you can see here on the right hand side of the screen, you'll see the locations for the photos I have previously mentioned. We're trying to standardize this process. These will be available during the summer of 2025, and come October 2025, it will be required for you to use the new test hole form. And here's a larger image of the SUE utility legend sheet. The SUE utility legend sheet has the quality level definitions on there, so you'll need to box in the QLA investigation, as you see here, and the abbreviations. So currently you are required to use the same abbreviations that were used during the QLB investigation. If there wasn't abbreviations for certain items that you want to abbreviate, you can add those to the abbreviations list on the SUE legend and then use those throughout the test hole forms. But if there's already abbreviations for that certain item, you are to use that same abbreviation that was previously used. Now we're getting into test hole forms. So on your test hole forms, at minimum, at the very top heading of your test hole form, you'll need this information as shown here with the county, the PI number, project description, and a plan reference drawing number. You know, which sheet is that particular test hole form on. You'll also need to display the north arrow, a screenshot showing the proposed conflict. As you can see here, test hole 403, the proposed conflict would be that storm drain. Displayed a legend, ensured abbreviations are appropriately used throughout the test hole form as previously mentioned. And a displayed scale that matches the scale of the plan set. Go over some examples here to determine if the consultant was able to find the target facility or not. So if you look at the first example, the targeted facility was a 900 pair telecom, and the crew's remark states that they found a 20 wide by 14.5 inch deep concrete duct, which is assumed to contain the 900 pair. You notice that the facility was not found, and that is because the concrete duct was not mentioned for the targeted facility. The bottom left-hand example, the targeted facility was an unknown size and type water, and the crews found a 9-inch ductile iron water line. The result was that the facility was found because previously it was an unknown size and type was the target. So they were able to add information to the investigation by determining the size and the material type of that line. The bottom right hand example, a 20-inch ductile iron water with a 30-inch unknown type casing was the targeted facility. The remark section states that a 31-inch steel casing was found, and they assumed that the 20-inch ductile iron pipe water line was inside of the steel casing. The facility was found because they found the steel casing that was recorded for the targeted facility. We're going to go over some additional examples. Number one, a 12-inch ductile iron water with a 20-inch unknown type casing was the targeted facility. The crew remarks states that they found a 20-inch steel casing. Assumed recorded 12-inch ductile iron water was inside the casing. Also found 2.5-inch plastic conduits for telephone. The result was that the facility was found because they found the same size steel casing that was recorded in the targeted facility. Number two, a 12-inch ductile iron water with a 20-inch unknown type casing was the targeted facility. Crews found a 16-inch ductile iron water instead of the 12-inch ductile iron water pipe with a 20-inch unknown type casing. So the result was not found because what they found in the field differed from what was shown on the UTLE previously, which was the targeted facility. Number three, the targeted facility was a 20-inch ductile iron water, and the remark states that they have found a 7-inch ductile iron water instead of the 20-inch. So the result was not found because it does not match the targeted facility information. Number four, the target was a 12-inch unknown water main. The remarks state that the crews found a 10.5-inch ductile iron pipe water main while looking for the 12-inch unknown water main. The result was that it was not found due to difference in size of what the target versus what was found out in the field. Number 5, unknown size and type was a target, so we don't have a clue what's out there at this point. We just know there's something there. So the crews performed a test hole and they found a 6.5-inch ductile iron pipe with unknown facility type. So the result was that it was found because they've added information to the investigation. Number 6, a 30-inch unknown water main was the target facility. Crews found a 20.5-inch ductile iron water main while looking for the 30-inch water main. The result was not found because the size differed between the targeted facility and what was actually located in the field. Preparing your QLA submittal, ensure that you're using the previously accepted UTLE DGN file. So if you're issued a job order from our office, we make sure that you have the latest UTLE file when we issue the job order, send you over the files. But if you're working under OPD's contract and you did not complete the QLB investigation and now you're doing the A behind someone else's work, you need to ask your prime to make sure that they provided you the latest UTLE file because there could have been revisions made to that particular project. So if you look down here at the very bottom left hand corner, the magenta colored 8-inch unknown type was the UTLE file, and the blue water line, which in a white box and white text on the right hand side, 8-inch ductile iron pipe, what was found during the QLA investigation, they were able to identify the material type. So if you completed the QLB investigation, you will place those updates in the DGN UTLE file. And if you did not complete QLB investigation, you will provide those updates into the QLA DGN file that you've created for the submittal that was mentioned earlier in the presentation. So when you place your test hole cells in the whether it be the UTLE file or the QLA DGN file, you'll need to make sure that they are legible. If you see on the left-hand side, the text are overlapping and you can't tell which is which. But on the right-hand side, you could see how the text had been adjusted and you could clearly see that the top cell is test hole 37 and the bottom one is 36. So on your test hole forms, you will need to ensure that the proposed conflict is shown as previously mentioned. If the pipe size or structure number is available, you need to list the size or structure number on your test hole form. In instances where conflicts no longer applies due to design changes, the SUE professional may record non-applicable for proposed conflicts. You are still required to perform this test hole at the location that was requested because this information could still be valuable during construction. It could tell the crews exactly the exact depth of that facility in that certain area because there may be another conflict in close proximity.
Good morning. I'm Raymond Chandler, and I will be continuing the plans production discussion. So on this slide, we see a CSV file. And this CSV file is a comma separated value Excel spreadsheet that will be provided with your deliverable. The information that's going to be provided is an arbitrary number for each of the test holes performed, the northern and eastern, the top of the utility elevation, feature codes for each test hole. Adder name is a inroads function that has to be included. And a description for each of the test holes and what was found. So I'm going to specifically talk about the feature codes here. In this example, they were performing test holes on the same utility. Test hole 1, test hole 4, and test hole 6. Test holes 1 and 4 were done before the manhole that is shown in the middle of the screen. And then test hole 6 was performed after that manhole. So in this CSV file, test hole 1 will have a feature code of SUE top 1. Then test hole 4 will have the same feature code SUE top 1. But then since a manhole is separating test holes 1 and 4 from test hole 6, a different feature code will be used for test hole 6. And as you see in this example, test hole 6 has the feature code of SUE top 4. The CSV file, as I stated earlier, will have the utilities, the top elevation of each utility. The reason for this is when the designer receives this CSV file, they will be using this file to plot the utilities on the drainage profiles. So please ensure that you use the top of the utility elevation, not the ground grade elevation in the CSV file. Now I'm going to transition to nominal versus outside diameter. I'm going to talk about what should be displayed in the test hole forms, the DGN file, the test hole tables, and also the CSV file. So in this example, on this test hole form, the target utility was 18-inch DIP sewer force main. What they located in the test hole was an 18.5-inch DIP sewer force main. So for located utility and in the cross-sectional view of the test hole form, the outside diameter should be recorded. In this next example, they were looking for a 4-inch plastic gas line, and what they found was a 4.25-inch outside diameter gas line, and that's what they noted on this form in the outer diameter size location, and also in the cross-sectional view they show the outside diameter that was measured. For water lines, in this example they were looking for 12-inch unknown water main, but what they found when they measured the outside diameter was a 13 1/5 inch DIP water main. So the outside diameter is what is recorded on the test hole form. What about DGN files? In this example, we're looking at a water test hole form, and for water companies, they normally provide the nominal size on the records. So in this case, they were looking for a 8-inch PVC water line. And when they did the test hole and measured the utility, they measured 9-inch DIP water line. So in the DGN file for water utilities, we ask you to show or record the nominal size of the water line in the DGN file. So in this case, the nominal size of this utility is an 8-inch DIP. In this next example, this is a sewer utility. On the sewer records, normally the nominal size is provided. In this case, they were looking for an 8-inch ductile iron sanitary force main. In the test hole, they measured a 9-inch Delta iron pipe, and in the DGN file, they will record the nominal size of that pipe, which is an 8-inch DIP utility. In the next example is a gas test hole. Normally on the gas records, the nominal size is provided. In this case, they were looking for a 4-inch steel gas main. They found a 4.5-inch plastic gas main. So what should be recorded is what they found in the test hole, which is, but they should put the nominal size. So the nominal size of this pipe is 4-inch, but what they found as a material type was a plastic instead of steel. So they must put the material that they found, which is plastic, and show that in the DGN file. Okay, so what about telecom? Telecom is you get a mixed bag with telecom. Sometimes they show the outside diameter, sometimes they show the nominal size for their conduit. So in this example, they were looking for a 4-inch plastic conduit, and what did they find? They found a 4-inch PE conduit. And for telecom facilities, we want you to put what you measure in the DGN file for telecom. So in this case, they found a 4-inch PE conduit, and that's what they found. That's what they record in the DGN file. AT&T 4-inch PE conduit. And a good way to remember this by using the acronym WIM-IWIP. And what does that mean? That means what you measure is what you put. So for telecom, what you measure is what you put in the DGN file. On this next slide, when the pair or fiber size is known for that telecom, then both the pair size and the outside diameter should be recorded in the DGN file. In this case, they were looking for an AT&T 200 pair telephone line, and what they found was a 1.5-inch direct buried cable 200 pair telephone line. So what they put in the DGN file? They put the outside diameter and the pair size of the utility in the DGN file. Okay, going back to the test hole table. In the test hole table, you should use that same phrase that I used before, WIM-IWIP. The outside diameter is always recorded on the test hole table. So in this case, all of these test holes show the outside diameter of what was measured in the test hole on the test hole table. And finally, in the CSV file, what should be shown in the CSV file? Again, use that WIM-IWIP for all utilities in the CSV file. What you measure is what you put. So in the CSV file, in the description, the outside diameter is provided. Thank you.
Hi, my name is Corbin Edwards, and I'll be discussing larger structures and multiple findings and how that should look in the test hole forms, the UTLE DGN, the test hole table, and the CSV file. Larger structures. Larger structures are defined as 24-inch pipes and larger, and all ducts. And as SUE professionals, you're required to include the top and bottom elevations of pipes 24 inches and larger, along with all duct banks. Record the outside diameter of the exposed facility and ensure your calculation of the elevations versus the outside diameter are correct. In the cross-section view, you can see a 38-inch pipe is shown along with the top elevation and bottom elevation both being listed. In the table below, you can see that the top and bottom elevations are also included in the table. How should that look in the DGN file? In the before picture on the left, you can see the label of 6 4-inch conduits, and during the QLA investigation, the crew found a 15.5-inch by 13.5-inch concrete telephone duct that is assumed to contain the record 6 4-inch telephone conduits, and the UTLE was updated with their findings of the duct bank and while leaving the record 6 4-inch conduits label. Larger structures in the CSV file and ensure that the bottom utility elevation is included. In this example, you can see that point 1000 and 1001 have the same northing and easting. However, the elevations are different for the top and bottom elevation, along with the feature codes being different, with the top elevation getting a feature code of SUE Top 301 and the bottom elevation getting a feature code of SUE Bot 301. Larger structures in the CSV file again. In this example, in the cross-section view, you can see a duct bank with the top elevation of 1019.2 and the bottom elevation of 1018.1. And in the CSV file example below the 2 highlighted rows, you can see the northing and eastings again are the same. However, the elevation of 1019.2 for the top has a feature code of SUE Top 1, while the elevation for the bottom 1018.1 has a feature code of SUE Bot 1. When you find multiple utilities in one test hole, on the test hole forms, each utility should be included in one form. Please do not submit multiple forms for each utility in the same hole. In this example, on the left, you can see that 2 duct banks were found during the investigation in the same hole, and 2 duct banks have been shown in the cross-section view. In the example on the right, 2 pipes were found in the same hole, and both pipes are shown in the cross-section view and with the top elevation of both pipes being listed. And in both tables below, you can see that the elevations for both structures or pipes that were found in the same hole are listed in the table below. Another example of multiple findings in the test hole form. In this example, the crew was asked to find a 16-inch ductile iron water main, and during their investigation, they found a 2.5-inch PVC conduit unknown utility and a 1-inch steel unknown utility, in addition to the recorded 16-inch ductile iron water main. And in the cross-section view, you can see that all 3 utilities are shown, and the top utility has a unique structure of structure number 1, and that is the 2.5-inch PVC unknown utility. And structure number 2 is the 1-inch steel unknown utility, and structure number 3 is the 16-inch ductile iron water main. In the table below, each utility is listed or separated by a / in the utility located column, and the elevations and depths for each utility that was found are included in the table. When multiple utilities are found in the same hole, how should that look in the UTLE file? From the example in the previous slide, you can see that both unknown lines are shown within the test hole cell. When multiple utilities are found within one test hole, ensure both are clearly recorded in the test hole table. In this example, test hole number 10, there were two 1.5-inch plastic unknowns that were found, and you can see that both the top elevation of each utility has been and depth has been listed in the table. When multiple utilities are located in the same test hole for the CSV file, they should both be listed, or all utilities should be listed in the CSV file. In this example, you can see for test hole 12, there was a 2.5-inch direct buried telephone and a 1.5-inch steel unknown that was found. And they both had the same elevation. However, the 2.5-inch direct buried telephone has a feature code of SUE top 9A, while the 1.5-inch steel unknown has a feature code of SUE top 9B. Another example of multiple utilities in the CSV file. This is the example from the previous slide where two unknowns were found along with the 16-inch ductile iron water main. And in the CSV file, the highlighted rows, you can see that the northern annealings are the same for each row. However, the elevation of each structure has changed, and the feature codes for each utility are different, with the feature code for structure number 1 being SUE top A, feature code for structure number 2 being SUE top B, and the feature code for structure number 3 being SUE top C. Anomalies and unknowns, and how those should look in the test hole forms, the UTLE DGN, the test hole tables, and the CSV file. In this example of an anomaly, the crew found an unknown width by unknown height concrete telephone duct and is assumed to contain the recorded 6 4-inch PVC telephone conduits. The crew was unable to measure the dimensions of the concrete telephone duct given the 53-inch by 6-inch concrete slab that was located directly above it. In the cross-section view, you can see that they have shown the 53-inch by 6-inch concrete slab, and below that they have shown a duct bank with a note noting the unknown dimensions of the duct bank. And in the table at the bottom of the slide, you can see that both structures have been listed in the table, with the elevations and depths of both structures also included. Another example of an anomaly. In this example, the crew found a 38-inch wide by unknown depth concrete telephone duct while looking for an unknown telecom. The crew was unable to excavate to the bottom of the duct bank due to rocks in a nearby storm drain. And in the cross-section view, you can see they have shown the duct bank. However, they have not shown the bottom of it since they were not able to excavate to the bottom. And if it was not found, it should not be displayed in the cross-section view. When asked to perform a test hole on an unknown line, it is expected for the SUE consultant to identify the unknown utility size, depth, and type. Not identifying the utility type is considered an incomplete investigation. When unable to identify the utility, the level of effort should be recorded in the remarks notes section in the test hole form. In the before picture, you can see that there was a test hole requested on an unknown line. And in the after picture, the unknown line was updated with a 13-inch DIP label. However, it remained an unknown line, and this is considered an incomplete and incorrect investigation. In this example, the test hole was requested on the unknown line below the highlighted 25-pair telephone in the before picture. And in the after picture, you can see that the line was updated. In the investigation, the consultant realized that the unknown was actually the 25 pair, and the UTLE was updated accordingly.
Hello, I'm Courtney Lovelace, and I'm going to continue the planned production discussion covering test hole forms and QLA DGNs when completed by a different consultant. When test holes are done by a different consultant from who completed the previous QLB investigation, only the designating and QLB work done by the QLA consultant will be shown in the test hole forms. In this image, you'll see all the QLB work completed with the previously accepted QLB screened back. This is incorrect. You will only show the designating and QLB work you completed during your investigation. This is an example of the QLA DGN, which is submitted per the checklist. You'll see the test hole cells and the designating line work completed by the QLA consultant. This line work should tie into the previously approved QLB line work. And please refer to ASCE 38 and the GDOT scope of services for any additional information. In this image, you'll see the line work designated for test hole 13 tying into the previously approved QLB line work. Now we'll move on to dry holes and how they are shown in test hole forms, the UTLE DGN, test hole tables, and the CSV file. When dry holes are encountered in the field, we want to ensure proper documentation is recorded in the test hole forms. In the notes and remarks section, be sure to include the actual depth excavated, any additional depth probed, any electronic depth readings recorded, and any reason for any issues that you encounter in the field, such as a high water table, excessive rock, or tree roots. In the cross-sectional view, if a utility is not found, a pipe or conduit should not be shown. And the actual excavated depth should be recorded in the cross-sectional view, the notes, and the test hole table. When a table is included in the test hole form, be sure a dry hole is clearly recorded under the utility located. Your northing, easting, station and offset, and ground elevation are recorded. For the elevation of utility, this should be listed as NA because no utility was located. And the actual depth is recorded for the excavated depth. In the UTLE DGN, an adjustment to the line work is not needed. The line work will not pass through the center of the test hole cell because the utility was not located and verified. In the test hole table, only the excavated depth is recorded for a dry hole. The top of utility elevation should be recorded as NA. Dry holes will not be included in the CSV file. After the SUE investigation, dry holes are reviewed for billing justification. The department does not pay for unjustified dry holes. All information provided will be considered, including the depth investigated, if any electronic depths are provided, if any coordination with the utility owner was done, and any additional attempts at adjacent locations. Consultants will be notified in a timely manner if dry holes are approved for billing, and you will receive justification if a dry hole is rejected. Now we'll discuss some file management and documentation. There should only be one test hole PDF form submitted. Please remove all individual test hole DGNs and PDFs. Consultants should only provide the requested files per the checklist. There should only be one UTLE DGN file included in the submission. When test holes are completed by the same consultant who did the QLB investigation, there should not be a QLA DGN included in a submission. When test holes are completed by a different consultant from who did the QLB consultant will be requested to update the database based on the QLA findings. This can include adjusting line work or labels. The QLB consultant will not need to add test hole cells to the UTLE file. A final UTLE will be provided to the QLB consultant after the QLA investigation is completed.
During this training, we spent a lot of time diving into the details. Now, we would like to pull you out of the weeds to ultimately look at the big picture and make sure the submission ultimately makes sense. On the slide, you will see an example of 3 test holes completed on a continuous duct bank, not separated by an appurtenance. So on the far left, test hole number 2, 4 ducts were found at a depth of 4.79 feet. Test hole 3, still 4 ducts were found at a depth of 4.72 feet. In test hole 4, only 1 duct was found at 0.85 feet. Ultimately, this will make the reviewer question if all the ducts were found, and we will likely send you back out into the field to ensure you have located all target utilities. The next example is another continuous duct. This time we had 5 separate test holes, and this duct line was not separated by an appurtenance as well. So test hole number 6, you see 2 ducts were found at a depth of 2.06 feet. But in test hole 7, only 1 duct was found at 0.88 feet. Then we have 0.92 feet, 1.69 feet. Then we have 2 ducts at 0.6 feet. So this information varied significantly from the other one. But either way, we should consistently see at least the same number of ducts and close to the same depths. Now we do understand there could be difference between ducts if there's settlement involved, and the gaps in between the ducts could vary. But transitioning from 2 ducts to 1 duct on a continuous line doesn't really make sense. So we just want to make sure that you all accurately depict your findings within the test hole forms. And when you're in the field, when you find these unusual situations that should flag your field crew to investigate further. Otherwise, you're going to submit to our office, and we're more than likely going to send you back out into the field to investigate further. You have the autonomy as well to coordinate with the utility owner when the findings are inconclusive or unclear. You are encouraged to use engineering judgment during SUE investigations. Ensure the data presented complies to federal and state requirements. Information should ultimately make sense. We are all engineers and need to use our engineering judgment. Together, we can ensure SUE maintains and/or earns credibility within all previously established engineering branches. Ultimately, we need to make sure a quality product is provided, which will have a good reflection of the overall program. As professionals, it is our responsibility to provide that quality that will ultimately benefit the project during preliminary engineering and ultimately during construction. Thank you all so much for your time and attention during this training. Here is our contact information. Please feel free to reach out to any of us if you have any SUE related questions or concerns. Thank you.